So now, some of you have heard of other machine learning techniques that are applicable to finance. In particular, you may have heard of meta-labeling. So it is worthwhile to understand what's the difference between meta-labeling, which is quite well known since the publication of the Advances in Financial Machine Learning by Dr. Marcus Lopez de Prado, and our notion of conditional parameter optimization. So meta-labeling is a technique to learn from a portfolio or a strategy's past track record, augmented with big data to predict the probability of profit of that strategy or portfolio. Whereas in conditional parameter optimization, we are also learning from the portfolio strategy's history, but this history typically is based on the backtest, not necessarily have a live history. It can be, both based on backtest, and also augmenting with big data. So far it's the same, right? So far the two parts are the same. The conditions are the same, but the objective is to optimize trading parameters. It's not to decide on capital allocation or leverage, but to optimize the trading parameters of a strategy. Now, clearly, when we talk about trading parameters, we are thinking about a quantitative strategy, an algorithmic strategy. Meta-labeling can easily be applied to discretionary trading, whereas conditional parameter optimization is typically, we are dealing with algorithmic strategy, where you have clearly defined parameters for entering trades or exiting trades, and also clearly defined backtests where you can find out how the track record would look like under different set of parameters, which is very difficult to do, as you can imagine, for a discretionary strategy, right? How do you reproduce the history in a discretionary strategy using different parameters? That's very tough. So only, really only this particular technique really only applicable to algorithmic strategy, where you can identify, where you can create backtest or simulation. Again, meta-labeling is to use the probability of profit that the machine learning predictive model established for risk management and position sizing. Determining what portfolio allocation you should use, deciding what leverage you should use. That's meta-labeling, and it's again well known since the publication of Advances in Financial Machine Learning. But conditional parameter optimization is different. It is to improve the base strategy's trading performance, not just using capital allocation to manage its risk, but actually changes to some extent the base strategies, because the parameters can be different for every trade. And meta-labeling typically use classification models in machine learning, meaning they are identifying whether the trade, the position or the trade or the portfolio will be profitable or not. So profitable or not are two classes, right? And applying probability to those two classes. Whereas in CPO, in conditional parameter optimization, we need to use a regression model. We actually need to predict the expected return of a strategy in order for optimization. So that's a more technical difference between meta-labeling and CPO.